I have the privilege of talking to one of the foremost astrophysicists in the world, no blood involved here, Notre Dame professor Timothy Beers. Professor Beers and his research group are known as Galactic Archaeologists, but instead of digging up artifacts on Earth, they're using telescopes and sorting through data to discover how galaxies are formed and how we came to be in this spot in the universe. That's a pretty spectacular job ahead of you. Tim, welcome to the studio this morning. Thanks so much for joining us. Tell us a little bit about what you do.
Well, it's a pleasure to be here. It's a pleasure to be here at Notre Dame. In fact, I brought with me a map, which is something that was constructed to illustrate part of what we do. Galactic archaeology is what astronomers call the study of the assembly of the Milky Way galaxy, our galaxy. And what we've learned over the last 20, 30 years is that our galaxy was not formed out of a big ball of gas, which is what people originally thought, but assembled piece by piece by much smaller galaxies. And the remarkable thing is that, as this map shows, it's still going on. We can look out into the night sky and pick out spots in the sky where there are other galaxies that are being accumulated and torn apart by the gravity of the Milky Way.
And why is it important that we understand how these galaxies are formed?
We all, especially at this university, are about origins. We want to understand the beginning. And this is part of the puzzle that has to be put together in order to set up deeper understanding of how this whole process began. Ultimately, the process that created everything around us, not just the stars themselves, but the planets, the elements, and all of the pieces of the equation that came to be in order to make it possible to be here today.
That's a pretty spectacular job when you think of everything that you are looking at. What is the most exciting thing on the horizon for you right now?
What we've been working on for a number of years is not just the assembly of galaxies, but the study of the origin of the elements. If you look at the periodic table, anything heavier than iron came from what physicists and astronomers call neutron capture reactions. And it turns out that we can actually study the products, not just here on Earth, but out in the stars themselves. And so what we do, what my team here at Notre Dame does, is we look out with the world's largest telescopes to study the chemical makeup of the oldest stars that there could possibly be. We have actually identified stars in the sky in our own galaxy, which were born no more than a few 100 million years after the Big Bang. So they have recorded, just like fossils, hence the connection with archaeology, they have recorded the chemistry of the early universe. And that snapshot on how it was is what informs us as to all the reactions and all the chemistry that took place between then and the formation of the Earth.
Well, that's some pretty exciting work that you are doing. We're going to let you go back to it today. Thank you so much for joining us, Tim.